the honor and I have the duty to give you two talks, a very short one about Ladislaus von Bortkiewicz and then another one to introduce the conference 200 Years of Finance and Statistics. Ladislaus von Bortkiewicz was here at the Berlin University, and the Swedish political economist, industrialist, the founder and first editor of the Nordic Statistical Journal, Thor Andersen, he wrote in 1931 in the obituary, I quote, "The founder of the present-day statistical science is William Lexis." He means Wilhelm Lexis. The greatest of his pupils was Ladislaus von Bortkiewicz, who was a professor at the University of Berlin. One of von Bortkiewicz's foremost pupil, Karl Freudenberg, has said that the classical period of theoretical statistical science began about 1876 with the publication of Lexis' first great work and ended on July 15, 1931, the day of the death of Bortkiewicz. Quote end. Bortkiewicz was born on August 7 in 1868 in St. Petersburg in Imperial Russia to a Polish family. There he got an excellent education, and first he studied there jurisprudence and law in St. Petersburg. And then later he studied at the Göttingen University, and you see here a map to get an impression how he traveled and how far away he had to travel to do all these studies. So at Göttingen University, where he got the doctoral degree, and then he studied in Strasbourg, in that time belonging to Prussia, to the German state, where he got this Privatdozent, which you can't translate. Habilitation, Privatdozent, that's so German, we have no other word for that. And he was influenced especially by Wilhelm Lexis, his advisor in Göttingen, and Georg Friedrich Knapp, in that time in Strasbourg. In 1898, he was 30 years old then, he published his first book, The Law of Small Numbers, in which he dealt with the Poisson distribution. And thanks to this publication, a brochure of only 60 pages, his name became widely known. After a short intermezzo in St. Petersburg, when he worked for the railway system, and furthermore he taught at the Alexandrovsky Lyceum, he remained in Berlin for 30 years until his death. Bortkiewicz was an extraordinary economist, statistician and mathematician, and at the Berlin University, in that time Friedrich Wilhelms Universität, he got a professorship, an extraordinary, außerordentlicher professor in 1901. And he became he got the professorship for economics, in that time Staatswissenschaft in German, and statistics. And from 1913 until his death, he was one of the directors of the statistical seminar, das Staatswissenschaftlich-Statistische Seminar. And you see he was together with Max Sehring, Heinrich Hertner, and Ludwig Bernhard, all were prominent economists at the university. And only in 1920 he got a full professorship ad personam, so to speak, ein persönliches Ordinariat. That means when he died, no successor can follow, because it was finished with this person who got this persönliches Ordinariat. In 1906, Bortkiewicz also became a professor for mathematics and statistics at the business school, where he taught until the winter 1922-23, and it was here in this building. In the classroom number 109, as we know from archive document, was a portrait of him. But in February 1938, the Pedell porter reported to the director that this portrait was missing. And he mentioned it was stolen because the persona who had done it were thinking that Bortkiewicz was not an Aryan. In German, the Pedell wrote, weil die Täter annahmen, sei nicht deutschblütig gewesen. The work of Bortkiewicz covered classical economics, population statistics, theory, mathematical statistics, theory of probability, mathematical economics, and physical statistics. The fields were very different, but they were related to the methods he used. He contributed to the development of all these fields and especially published what would become classic works in mathematical statistics. He published many articles, but no complete volumes of his numerous investigations. He was very high acknowledged by the mathematicians, by the economist Joseph Schumpeter and the mathematician Emil Julius Gumbel. Both had to go into exile because of the Nazi regime. Both published about Bortkiewicz in exile in 1960, respectively 68. And according to Schumpeter, by far his most important achievement is his analysis of the theoretical framework of the Marxian system, the articles published in 1906 and 07, much the best thing ever written on it, and incidentally on its other critiques. A similar masterpiece is his paper on the theories of Wendt, of Rodbertus and Marx. End of quote. Until his death, Bortkiewicz lived in Berlin-Hallensee together with his sister Helene von Bortkiewicz. Here he died on July 15 in 1931 after a long illness. He was very famous in Berlin because the daily newspapers Berliner Tageblatt and Vossische Zeitung published obituaries on him. On the memorial ceremony, his colleague from the university, Professor for Economy Hermann Schumacher, was the speaker, and related to the fact that von Bortkiewicz never was married, Schumacher pointed out, I quote, Bortkiewicz hat sich der Wissenschaft mit einer Hingabe gewidmet, als ob sich auf sie das Bibelwort bezöge, du sollst keine Götter neben mir haben. Vor allem betrachtet er es als heilige Pflicht, den Schatz mathematischer Erkenntnisse aus 1,5 Jahrhunderten in seiner Wissenschaft zu hüten und vor Beeinträchtigungen zu bewahren. End of quote. He explained that Bortkiewicz was living like taking seriously what in the Bible is only you have to pray God, and in his case only to have to pray science. When Helene von Bortkiewicz died in October 1939, probably all papers of von Bortkiewicz were gone, or many of them. Thor Andersen described in his obituary very detailed that there were existing 25 boxes with manuscripts. And Thor Andersen had the idea to publish collected papers, but he died in 1935. And with the establishment of Ladislaus von Bortkiewicz share, he comes back to Berlin. So now we're moving back 150 years in the 18th century to looking on the traces of Daniel Bernoulli between Basel, St. Petersburg, Berlin and Basel. And when I was thinking that I have to give these two talks together, I was thinking what is common between Ladislaus von Bortkiewicz and Daniel Bernoulli. So they have something in common. That's first their interest in mathematics, in statistics, in theory of probability especially, but also their lifestyle. Like Ladislaus von Bortkiewicz, Daniel Bernoulli lived alone, taking the myth for granted to serve only the science. Daniel Bernoulli's life shifted between these three towns, Basel, St. Petersburg, Berlin, and one has to include Paris. He was born on February 8 in 1700 in Groningen, because his father, Johann, held a position as professor for mathematics there. In 1705, the family moved to Basel, and the father got the professorship for mathematics there. Johann won Bernoulli, his younger brother Jakob won, and their nephew Nikolaus won. So please look on this family tree. They were the founder of an unusual, extraordinary dynasty in science, respectively in mathematics. Unfortunately, this dynasty was existing only 3 generations, and it ended, by the way, in Berlin. This Johann III, he became a member of the Berlin Academy of Science, director of the observatory, which belonged in the 18th century to the Academy, and he died in 1807 in Berlin-Köpenick. The life of Daniel Bernoulli was related with 3 important factors. First, he grew up in a family of famous mathematicians, to mention only his father and his uncle Jakob. Second, his academic career was possible thanks to the existence of 4, in the 18th century, most powerful academies of science. The Royal Society in London, founded in 1660, the Académie des Sciences in Paris, founded in 1666, the Academy of Science in Berlin, founded in 1700, and the Academy of Science in St. Petersburg, founded in 1724. His career was linked with each of these academies, and he became a member in each of them. And third, he was witness of and actor in this great intellectual movement in the 18th century, which we call the Enlightenment. One of the symbols as well as the result of this development was the publication of the encyclopedia in Paris, the Encyclopédie au dictionnaire raisonné des sciences des arts et des métiers, and it was published between 1751 and 1780, and 35 volumes were published. And it was under the direction of Denis Diderot and the physicist and mathematician Jean-Baptiste Laurent d'Alembert. D'Alembert was a colleague and a competitor of Daniel Bernoulli, as well as of Leonhard Euler. And finally Euler, the greatest mathematician in the 18th century, and he was a friend of Daniel Bernoulli. So looking on the history of the Berlin Academy of Science, we find these 3 mathematicians in an active role. Euler played an enormous role for the Berlin Academy. Bernoulli, Daniel, was a member of the Berlin Academy, and d'Alembert should become the president of this academy, but he rejected. In this triangle, Basel, St. Petersburg, Berlin, in the local environment and in the global, the Enlightenment in Europe, and ad personam, Bernoulli's, Euler, d'Alembert, in this triangle life and work of Daniel Bernoulli was located. So first Basel, of course, he was educated here, he studied medicine, but he wasn't successful to get an academic position here. Until the 19th century, it was existing only one university in Switzerland, in Basel, established in 1460. His father Johann held the chair for mathematics, and he was a very dominant figure. There are many anecdotes about him and his bad relation to Daniel. And perhaps this was one of the reasons that Daniel studied medicine and not mathematics, like his older brother Nikolaus II, and his younger brother Johann II. With his older brother he will go to Russia, with his younger brother he will become a member of the Berlin Academy. And Daniel studied not only in Basel, he also studied in Heidelberg and in Strasbourg, so long before what we call today Bologna process in Europe. And then he received his doctoral degree in medicine in 1723 at the Basel University. And he was looking for an academic position, for a job. He tried 2 times to get a professorship at the Basel University, first for the chair for anatomy and botany, and the next year for the chair for logic, but he lost 2 times. And the word lost is true, because in that time, since 1718, the procedure to find the candidate for a professorship at the Basel University was the following. 3 candidates were selected secretly by the professors in the faculty, and then they drew lots, and this was the final decision. So Bernoulli lost. Between 1723 and 25 he traveled to Italy, and he was especially then in Venice, and learned practical medicine from the, in that time, famous physician Pietro Antonio Michelotti. And then he got an invitation to come to a country with rumors about it that it was a wild country and that it was cold and without European culture. But there were also rumors that there a new intellectual life will be established with great chances for young scientists, good working conditions, and many support. In 1725, Daniel and his elder brother Nikolaus traveled to St. Petersburg, to the Venice of the Baltic Sea, on the invitation of the new Academy of Science. By the way, the trip took 2 months. 1 year ago, in 1724, the Academy was established in the new capital of Russia, and the founder and protector, Peter II, Peter the Great, died unfortunately in the same year, but his widow Katharina I fulfilled the wish. The new academy was established to help Russia to become a modern European country, to develop its science and engineering. And although the Petersburg Academy and the elder Berlin Academy have one and the same intellectual father, namely Gottfried Wilhelm Leibniz, there were some differences. The most important difference was that the scientists who became members of the Petersburg Academy had also to teach, because only in 1755 the first university was opened in Russia, the later Lomonosov Moscow State University. So therefore Daniel and Nikolaus became not only full members, membre ordinaire in that time of the academy, they also were appointed as professors, Daniel for physiology and Nikolaus for mathematics. The members of the Russian Academy of Science had many duties in this time. They had to teach special courses, although for a small audience. They had to do their scientific research, to report the results in the sessions of the Academy, to publish in the new journal, Memoir of the Academy, and they also had to give different advices for projects, from theoretical expertises until real practical advices, for example, to construct new powerful ships for the Russian Marine. On the other hand, they were thankfully accepted, relatively well paid, and their status as academician was relatively high. And they hold several privileges. So, for example, to support the exchange with colleagues in Western Europe, the Academy in St. Petersburg paid also the, in that time, high mail costs. And finally, a publisher was founded to publish all works of the members of the Petersburg Academy. So very soon Petersburg Academy was acknowledged, and the Petersburg Academy and their academic sisters, so to speak, in London, Paris and Berlin exchanged information and literature, but they also became competitors to invite the best scientists. The situation for Daniel Bernoulli in Petersburg was ambivalent. So on the one side, he held an extraordinary position as a young scientist. On the other side, he didn't want to stay there longer. His brother died already in August 1726 because of lung disease. And so in 1727, he got his professorship for mathematics. And although he became a close friend of Euler, who was in St. Petersburg since 1727, and became the successor of Daniel as a professor for mathematics, Daniel wanted to go back to Basel. Daniel Bernoulli had done his research very successful in Petersburg. Besides medical topics, he worked on a mathematical theory of risk. He was thinking about the basis of a modern science of value. And probably in 1731 he wrote the paper, which came out in Latin, and I give you the English translation, The Exposition of a New Theory on the Measurement of Risk, which was published in 1738 in Petersburg in the series of these volumes of the Academy. But it was only in 1896 it was first translated into German and edited by the mathematician Alfred Pringsheim. You see here, and it was published in this series. So Alfred Pringsheim probably, or it's a pity, he is known in Germany mostly today as the father-in-law of Thomas Mann, but he was a very famous mathematician. And by the way, this publication, as well as an English translation, is still available. You can order the books via Amazon. Daniel Bernoulli wrote this paper because of his interest in theory of probability. I hope we'll hear something later. His concrete question was how to calculate the value of an asset. In contradiction to others, Bernoulli assumed that the value of an asset can be different for each of the participants, that the value of the asset depends on the capital the player had already. And then Pierre-Simon Laplace used the solution of Bernoulli in his Théorie analytique des probabilités. He made the same assumption, and he introduced the terms fortune physique and fortune morale. And his publication in 1816, he explicitly mentioned Bernoulli. And via the publications of Laplace, political economists learned about this theory and became interested in because of the theory of marginal utility, Grenz-Nutzen theory. So thus the Bernoulli formula and the theory of fortune became important also for economists. Furthermore, in St. Petersburg, Bernoulli wrote most of the manuscript of his famous Hydrodynamica, but it came out only in 1738. By the way, it's a pity that we can't go on the ship today evening. It fits so nice to the Hydrodynamica of Bernoulli. In 1733, after being 8 years in St. Petersburg, Daniel Bernoulli was able to leave the town, became a professorship in Basel in anatomy and botany, not in mathematics, and in his luggage he took with him the manuscript of his Opus Hydrodynamica. And he traveled together with his younger brother Johann, who visited him in Petersburg. And another 8 years later, in 1741, Leonhard Euler also left St. Petersburg because of the political changes in Russia. Euler was invited by the Prussian king Frederick II, who wanted to reorganize his academy, and he wanted to have the greatest mathematician in Berlin. The Berlin Academy was founded in 1700. In 1710, the first Reglement Statute was established, but later the academy slept in. So when Frederick became the king of Prussia in 1740, he reopened the academy, which was under his patronage. Thus, Euler belonged to the first scientists who were invited to become a full member, membre ordinaire, of the Academy of Science, and he became the director of the mathematical class. But for Frederick II, the most favored scientists came from France. Therefore, he invited the French mathematician, astronomer, and philosopher Pierre-Louis Moreau de Maupertuis to become the president of the Academy. Maupertuis was introduced only in spring 1746, so the reopened Academy voted in 1746 to nominate new scientists as members, as membre ordinaire, full member, as well as membre externe. And this session was made on June 30 in 1746, and they were elected in total to 20 new external members, among them Daniel and his brother Bernoulli. So you see, this dynasty Bernoulli is also interesting, looking on the membership of the Berlin Academy of Science. 6 members of the family became members of the Academy of Science in different times. But one has to underline that the nominations of members of the Academy belong to the king. Although the academicians who lived in Berlin, the académiciens ordinaires, voted secretly pro or contra the candidates, the last decision was made by King Frederick II. His yes or no was crucial. You see here, this is the only document we have in the archive of the Berlin Academy of Science on Bernoulli. This is a personal letter handwritten by Frederick II, in French, of course. Frederick II preferred French. And here he is writing that he is agreeable that Monsieur Bernoulli, that not I have made, it was made handwriting underlined centuries ago, so that he is agreeing Monsieur Bernoulli becomes a member of mon academy, of my academy. A tableau of all members of the Berlin Royal Academy of Science, and in the archive it looks very nice, big paper. This shows you the structure and the persona in 1768 of the Royal Academy. There were 4 classes, no president, see on the left, la place c'est vacance. In total, there were 26 académiciens ordinaires, and in total 131 académiciens externes. In the class de philosophie expérimentale, there were 7 full members, 33 external members, and here you see Daniel and Jean Bernoulli. Jean means Johann. In the class des mathématiques, there were only 4 full members. The director was now the successor of Euler, the French mathematician Joseph Louis Lagrange, who moved back to Paris in 1787. And you see the nephew of Daniel, the astronomer Jean Johann III. There were 34 external members, among them Leonhard Euler and his son Johann Albrecht. They were now already 2 years in St. Petersburg. In the class de philosophie spéculative, there are 6 full members, 35 external members. You can find here the botanist Carl von Linné. And in the class de belles lettres, there are 9 full members and 29 external members, and you see here among them the famous philosopher Voltaire. After the death of Maupertuis in 1759, Leonhard Euler was not de jure but de facto the director of the academy, but Frederick II was looking for a French one, so thus d'Alembert was invited to be the next president, but he rejected. And you see, 10 years later, the place is still vacant. In all these years, Euler and Daniel Bernoulli were in close contacts, and their correspondence survived. It was partly published in 1848 in St. Petersburg, thanks to Paul Heinrich Fuß, the son of Nikolaus Fuß, and Nikolaus Fuß was first a pupil of Euler and later his secretary, and later the secretary of the whole Petersburg Academy. And I only can recommend you to read these letters. It's an excellent source for historians of science, of mathematics, as well as the letters between Daniel Bernoulli and Christian Goldbach. And because of the time, I can't give you nice examples of these letters, what they exchanged, which ideas and all these things which happened. And Euler and Bernoulli, they studied very often the same problems, they worked on the same topics, they exchanged their thoughts, their results on hydrodynamic problems as well as on mathematical and practical problems. So, for example, only one I give you, Euler, Daniel Bernoulli and d'Alembert, they studied the problem of the vibrating string to find the equations as solution for a vibrating string. And beside these exchanges, they were also competitors to solve different problems which were announced in the so-called prize questions. And in Berlin, Euler introduced Daniel Bernoulli in the sessions of the mathematical class, so he presented papers Daniel Bernoulli wrote, and these papers then were published in the series of the Berlin Academy of Science. So in 1754, for example, it was a paper Daniel Bernoulli wrote about the vibrating string, and in the same year about the isochronon problem. So thanks to the correspondence, we also know Daniel Bernoulli propagated the theory of gravitation, Newton's law of universal gravitation, in Europe. In 1733, Daniel Bernoulli traveled to Basel via Paris. He came back to the roots, and shortly he finished his volume Hydrodynamica in 1734, and the publication came out only in 1738. First he wanted to publish it in St. Petersburg, that we know from the letters between Euler and Bernoulli, and then he found this publisher in Basel. Daniel taught anatomy and botany at the university where he studied and where his father still taught mathematics. He tried to get a professorship in science, and finally in 1750 he became the professor for physics and speculative philosophy. Daniel Bernoulli taught at his university more than 40 years, from 1733 until 1776. And then he asked his nephews, Daniel too and Jakob too, to teach instead of him. Daniel Bernoulli became a prominent person in Basel, an acknowledged citizen who was interested not only in science. He suggested, for example, to introduce a statistics of illnesses. It's a nice example to illustrate how these different scientific interests were combined. The fields of statistics and the application of the theory of probability were those fields where his mathematical interest and his medical knowledge come together, were linked and combined. Daniel Bernoulli became a famous scientist and mathematician. I told you already, he became member of all these 4 academies of science, and he participated in these prize questions. Prize questions were a form of stimulating scientists as well as propagate science and philosophy in the era of enlightenment. The Paris Academy was the first who announced every year an open question, a prize question. It was asked for an essay to describe the problem, to give a solution, or to construct certain things. Sometimes the prize question was repeated the other year when no essay was sent in or no good one. The jury who donated the winner was consisting of a group of the academicians, of the membres ordinaires. The essay contest in Berlin began in 1746, and the Berlin Academy followed with these prize questions the Paris Academy. The prize question in 1746 was on the wind, and the winner was D'Alembert, and Daniel Bernoulli was only the second, although he was invited by Euler to participate. To give an impression how broad the scientific interest of Daniel Bernoulli was, one can study the manuscripts he had sent to the Paris Academy to participate in these prize questions. The overview shows his interest, his talent, and also his competitors. Bernoulli was often very successful. Between 1725 and 57, so in 30 years, he won 10 times a prize question contest of the Paris Academy, 5 times alone and 5 times together with colleagues. But this was not in every case a very nice one. When he won the prize in 1734, it was an astronomical question, he had to share the prize with his father Johann, and it came to very unfriendly reactions of his father. The father was not proud on his son. In contradiction, he hated the son as a competitor. In 1740 it was different. The question was to develop a theory of ebb and flow, and Bernoulli had to share the prize with Leonhard Euler and Colin Maclaurin, the Scottish mathematician. And in 1746 the question was to develop a theory of magnet. He had to share the prize again with Euler, with his brother Johann, and with one who was called Dutour. It was his synonym, obviously. Although Daniel Bernoulli was famous and acknowledged, his collected papers, so to speak, in 8 volumes were published only after the 200th anniversary of his death from 1982 onwards. And it's sad, but until today we're still missing volume 4 and volume 6, and I gave you here the list of contents of all these volumes. The volumes are published in, or the papers of Daniel Bernoulli are published in these volumes in the original language. So in Latin, for example, when he published it in the 18th century in Latin. And we still miss volume 4, Hydrodynamic 1, and volume 6 on elasticity. His style of thinking one can characterize with 3 elements. He tried to find out the simplest as possible method to solve a problem, to find out the simplest way for a solution. Second, and this is in contradiction to D'Alembert and his approach, Daniel Bernoulli used mathematics as a tool. Mathematics was a tool to solve problems. And third, he was not only a mathematician, a theoreticist, he also was an experimentator, and he often made experiments to verify his theoretical thoughts or to verify his calculations. Then in 1882, a memorial ceremony was held in Basel on the 100th anniversary of the death. The Swiss professor Fritz Burkhardt remembered how beloved Daniel Bernoulli was in Basel, and that he liked to have guests and meet friends and colleagues, and mostly every citizen knew him, and the young inhabitants were trained to greet him on the streets. Die ganze Stadt kannte und verehrte ihn. Eine der ersten Anstandsregeln, welche ein Vater in Basel seinem Sohne gab, war, auf der Straße Herrn Bernoulli zu grüßen. And the other aspect of his life was his lonely life. It is unclear why he lived alone. His close friend Euler had a family, and his brother Johann had one, and other colleagues too. And the medieval ideal of a scientist living like a monk was over. But when scientists lived without a family, this myth was used as an interpretation as well as an explanation as to remember this ideal as a role model again, to serve only science. In the words of Burckhardt, war nie verheiratet und fand den ledigen Stand passender für den ruhigen Verlauf eines der Wissenschaft gewidmeten Lebens. In 2006, Franz Cerullos published this article, Daniel Bernoulli and Leonhard Euler on the jet ski, and this looks a little bit different from a quiet life serving science only. And you find this in the volume in honor of David Speiser, and yeah, Cerullos wanted to publish a very unconventional essay, but it has to do with hydrodynamics and with the concepts of Bernoulli and Euler on hydrodynamics. Thank you.